Testing 1 2 3. Testing 1 2 3.
Right now seems like no one is joining yet, so let's wait for another 5 minutes, then we'll start. Morning, guys. So let's get started. It's already 9:06. So last week, someone is asking about whether how you can access these lectures likes, right? So I asked I asked about this, and management told me that you guys have to subscribe to our package. It's a one-time subscription fee, and you have access to all the exercises and the lecture notes and the lecture slides in our platform. And regarding this, you can refer to the first lecture. So introduce a little bit about our subscription package. It's a one-time subscription. And let's get started for today's class. So today we'll continue to talk about for loop, and we will also introduce a new kind of loop which is called while loop. And okay, let's have a recap on what we have talked about last week. Last week we talked about switch. Switch is something very similar to if else control structure. So switch case is something very similar, but switch can make sometimes can make your code cleaner. So let's say, for example, you have this kind of very complex if else. So maybe you can think about whether you can utilize switch case to make your code looks cleaner. So let's find an example of switch case. Yep, this is a template for switch case. So for switch, you have a condition checking, and then you have a matching value for this condition. And for example, if this is a character, you can match each of the character here. Like for example, if case is A, then we execute something, we do something. And after your logic is fully executed, now you can write a break here to break out of this switch case. If a break doesn't exist here, then it will fall through to the second case. And then the logic or the statements here will continue to be executed. So remember to write a break here to break up of the switch case. And other than case, there is a default as well. That means if none of the above case matches, then default case will be matched and those statements here will be executed. So here is an example. We pass in a number, and if the number is 1, then we print out 1. If the number is 2, we print out 2. Otherwise, we print out 0. So this is all about, I think this is all about switch case. And then last week, we talked about for loop. For example, if you are given this kind of requirements, you are being asked to print out this string for 10 times. How would you do so? Are you going to write this code 10 times? It's not scalable, it's not that practical. What if that person asks you to, what if the requirement required you to print out this string 100 times, 1,000 times? You have to write this code 1,000 times. So now actually you have to utilize for loop or while loop or some kind of loop structure to make your life easier. So the right way to do it is utilize a for loop. So let's look at the for loop template. In a for loop, first you have to initialize your loop variable. So let's say this is a loop variable. And then before the for loop is executed, there is a conditional checking here. So this comparison, if this condition is true, then the statements in your for loop will be executed. If this condition or if this expression is calculated to false, then your statements here won't be executed. And every time after your statements are executed, then we execute this increment or decrement part. So after all the logic here are being executed, now we increase I by 1. And now after the first loop, your I will be 1. Okay. So the comment here is saying the first part is to initialize a variable for counting the loop. And the second part is to determine, is an expression to determine whether to stop our for loop, to determine when to stop the for loop. So in this case, if I is greater or equal to 10, the for loop will stop. Otherwise, if I is still less than 10, the loop will be continued. The third part is what we executed after the statements are being executed. So the third part is for increment your I, is to manipulate your I, your counting variable. And remember to put a semicolon over here to separate these three parts. And if we take a look at this example, there's a for loop here and the initialized integer I as 0. And the loop will continue as long as I is lesser than 10. And every time the I for, like, for every loop, the I will be increased by 1. So what will be the output? The output will be, first time it will be 0. And then it loop until 9, until it's less than 10. So it will be 0 to 10 to 9, 0 to 9. So the output of this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So how about this? Previously, we are asked to print out this string 10 times, right? So we can change it into a for loop. So for I equals 0 until I less than 10, I plus plus, and then print out this string. What if we want to print out 9 to 0? It's possible as well. So initialize your I as 9. And then the exit condition is if I is greater or equal to 0, then we continue the loop. But if I is lesser than 0, then we exit the loop. And for every loop, we decrease I by 1. So this loop will be executed 10 times from 9 to 0. And 9 to 0 will be printed out. There is an example which we have gone through last week to print out 10 asterisk symbol. So it's fairly simple. And also another example to print out a list of positive number n from 1 to n. So this is fairly simple. So if you understand the concept of for loop, so this is very simple. And also there's another example in our platform to print out from 0 to 100, print out all of the number which is a multiplier of 3. Not like a multiplication of 3. So yeah, this is not, it's not hard also. And the tricks here is to utilize I percentage 3 to calculate the remainder of 3, the remainder after divided by 3. So if the remainder is 0, that means this number, this I is a multiplication of 3. And this is also one of the example in our platform. So given the following list, print out 4, 15, 26, 37. So you have to observe the pattern. The pattern here is number is increased by 11 every time. 4 increase by 11, increase by 11. And then in your for loop, in the third part, you can control the third part to increase by 11 every times. I think we go through it already last week, but right. And you initialize your counting variable as 4, and then the exit condition is that it have to be lesser equal than 268. If it is larger than 268, end the loop. Yeah, something like that. Okay. So let's look at another example. Please use for loop to enter 5 results and display the mean result. So if you are given 5 number, now calculate the mean number, the average number. In order to calculate, to allow the user to enter 5 variable, if you doesn't know for loop, so what we will do, maybe we define a variable for 5 times and then read it from input for 5 times also. So you copy paste the cins for 5 times. And then after that, you just hard coded your code plus pass it 5 times and then divide it by 5 and print out the and then print out the average sum. Sorry, this prints out the average number. So this is very tedious. What if you are being asked to collect 100 score and calculate its average, or 1,000 score and calculate its average? So it's not practical. So the right way to do this is to utilize for loop. How can we do so? So this is an example. So we define score first. We just define one score. One is enough. Okay. And then create a loop that loop for 5 times. So this for loop for 5 times. The control structure here is we let I equal to 0, and then I have to be lesser than 5 in order for this loop to run. I have to be lesser than 5. And every time after a loop is run, I plus plus. So this will be loop 5 times from I equal to 0 to I equal to 4. Okay, it will be loop 5 times. And each times we read in a score. And then actually this code is incorrect. Why is that so? Why is this code incorrect? Because you see here they calculate the score 5 times and divide by 5. But it's incorrect because this score is only storing the last input. The previous inputs are lost. They are being overwritten by the later input. So to make this correct, every time when we read in a score, so every time when we read in a score, we have to manipulate the sum. We have to calculate the sum every time we read in a score. So we can define a sum up here, and then every time when a score is read in, increase the sum as well. So after we loop for 5 times, the sum will be the actual sum, and then we just divide it by 5. So previously, this is very, very wrong. We read in the score, and then after we read in 5 score and we store the score into this score variable, and then at the end, we add up all the score and divide it by 5. So this is very wrong because all the previous score are being overwritten. Only the last score preserved. The last input is preserved. So this is very wrong. And there's some visualized thing here. So initially sum is 0, then we read in the score which is, let's say, is 60. And then now we are going to sum equals sum plus score. That means initially sum is 0, then plus 60 becomes 60, and we store it back. We store this total back into sum. So now sum will be 60. And then another time in the next loop, we read in 70. So increment 60 with 70, sum plus score. So 60 plus 70 and store it back to sum. So this sum is 130. So 130 is stored back into sum. So and so on and so forth. So at the end, sum will have the sum of 5 score, and then we can divide it sum by 5 to get the average. Okay, there's another sample here. Actually, last week we go through this example already in the platform. So allow user to enter 5 numbers. Each time, allow the user to enter 5 numbers and then display the results after this number is multiplied by 3. So user enter 125 until 13, we output 375 until 390. Something like that. So how can we do so? So it's something similar to the above structure. So we have a loop like this, and every time when we read in a score, we actually can output immediately. So we output score times 3. Yeah, it's fairly simple. Also, another sample, allow user to enter 5 results. And then if the result is greater than 59, and then we have to like categorize it. If it is greater than 59, then it is considered pass. Otherwise, it is considered fail. And now we have to print out how many fail and how many pass. So we go through this sample as well last week. So we have to utilize some other variable. So we have to create a variable called like pass count and fail count. So every time in the loop, if we determine that this number being inserted, this number being input is fail, then increase your failed count by 1. And if it is pass, increase your pass count by 1. And then at the end, print out the pass and fail count. So we go through this as well last week. And there is some, so let's talk about some tips about debugging. So for loop is very, very powerful, but at the same time, also sometimes you'll find it hard to comprehend. Sometimes the code, uh, it makes the code a bit complex because now your code doesn't just run one time, it runs again and again. So debugging is very important here. So let's say if you are given a code here, so this is a very basic for loop, right? It loops for 10 times. We initialize integer I here. But there is something to note. If we declare and initialize our integer here, this integer only exists in the for loop. It doesn't exist outside of the for loop. So there is a note here. If you declare a variable inside the for loop, the life period of it would be ended after this for loop is ended. Okay. So for example, if you are given this code, you declare your I here. And after this for loop, we're trying to print out this I, which throws error. Let's try this by ourselves. For in integer I equals 0, I less than 10, I plus plus, print out I. Okay. Also, we want to print out I here. Is this allowed? No, it's not allowed. Throws error. It's saying that in line 10 or this is in line 10. In line 10, I was not declared in this scope because I is declared in the for loop and it doesn't exist anymore outside of the for loop. So how can we make it exist outside of the for loop? We have to declare it outside. So we can declare I equals 0 outside. If you don't initialize I will be given a default value. So for integer, the default value will be 0. Or you cannot initialize it as well. It will be 0. Yeah. So now, if you declare it outside of the for loop, so it still existed outside of the for loop, and it exists inside the for loop as well. So this is the difference between you initialize, or sorry, you declare the number, you declare a variable inside a for loop or outside a for loop is quite different. So so this doesn't work right. So in order to fix it, we can move the declaration of variable I outside of for loop in the main function. So if you declare a number I here, a variable I here inside main function, so the lifetime of it will be until the end of the main function. And usually there are two types of error. First is syntax error, another one is semantic error. And what is syntax error? Syntax error is like if you have typo and you forgot to put a semicolon at the end of the statement, or you forgot to put a curly braces for your if else control structure, or you didn't have or your for loop doesn't quite follow this template and you got typo, or you miss this semicolon, and or you miss this parenthesis. So many things can cause syntax error. And how about semantic error? Semantic error means you design the you design the program to do something, but it doesn't do something as what you expected. That is semantic error. And then now we have to debug to see why it doesn't do what we want, what is wrong. Maybe the logic we write is not correct. There is something wrong in our logic. This is considered semantic error. So for example, there's a sample here. If you are given a code here to print out, so you're given a for loop to print out number 0 to 9. We need, so let's look at this code. Initially, we declared n as 10. Okay, and then we start this for loop. I equals 0, I greater than I plus plus, and then very obvious, like they missed the closing curly braces. So this is very obvious. Yeah, it's very obvious. So you see why we can notice it so easily, because there's open curly braces here and there's no closing curly braces here, right? The way we return the code is written make it easy for us to spot this issue. So this is a good practice. You see, they have tab before their code. Inside their for loop, there's another tab as well. So this makes the code cleaner and easier to look at. So let's look at an example. When you write your code, if you didn't indent it properly, if you write your code like this, then it will be harder to spot any issue. It looks like, right, this code just looks messier. So a good practice is always indent your code. And for example, the common practice is for integer main, we have no indentation, and everything inside main should have an indentation of one level. So just tap once. So you should have one tab in front if since they are inside main. So every time so the common practice is every time if there is a curly braces, everything inside this curly braces should be indented by one tab. So there is a curly braces here, right? So indent by one tab. And remember to close these curly braces. What if you have another if here? If something and then else something, then remember for the indent structure. So tap for one also if it's inside the curly braces. Yeah. So this way our code looks cleaner. Otherwise, if there's no indentation, it looks like this and it's a mess and very hard to debug also. And very hard for others to understand your code. Okay, so here the issue is expected a curly braces at end of input curly braces. And yeah, we miss a curly braces. And also, seems like this is a syntax error, right? We miss a curly braces. The code doesn't compile. So after that, the code actually compile, but doesn't works. It doesn't works as what we want. Let's try this. It doesn't output high. Why is that so? Because here inside for loop, we define an I and we initialize I to 0. And the loop will only be executed if I is greater than n. I is 0 and I is not greater than n. Thus, high will not be printed out. So to make this works, should write something like, what if we want it to print out high 10 times, so it should be as long as I is lesser than 10, since n is 10, right? As long as I is less than 10, then print out high. So it will print out 10 times. Yeah, so it print out 10 times. So this is an example of semantic error. That means everything looks correct, everything looks right, but then it just doesn't work as what you expected. So it's a semantic error. So for semantic error, we have to debug it. So there's some tips for debugging. First, look for the root cause. And then try to understand why it happened. And then come up with a solution. And then execute your solution. And make sure that this doesn't happen again. And like remember this kind of issue and make sure it doesn't happen again. So how can we debug? The simplest way is to print out cout, is to print out something. For example, here, let's say let's say this height is not being printed out, right? So now we are very curious about why is that so? You can print out something like print out I. So I is not defined. And or in order to debug, we can like move I to outside. And then we print out I. So I is 0. And then we can ask, is I greater than n? I is not greater than n. So this Boolean number 0 means it's false. So I is not greater than n. That is why this loop will not be executed. So this is a very good clue to us. And in order to make I greater than n, maybe there's something wrong with our control structure here. It should be I lesser than n. Yeah. So this is a sample of using cout to debug your program. And also another method is also this is also a very common use method, is to comment out some of the code. So if after you commented out some, like if your program always doesn't work right and you commented out some of the code which is suspicious and suddenly your code works, that means the issue is with those code that you have commented out, right? So, or also sometimes if your code is super long, during debugging, you just want to debug a tiny part of your code. So you can comment out all those code that doesn't matter. So that you can focusing on debugging the part that you actually care about. This is about commenting. In order to comment out the code, you can type control slash to comment the code. You can comment many code together also. Control slash. And then yeah, cout can help to understand how the program executes. And also there's one very useful method as well, which is not mentioned here. We can do step-by-step debugging. So let's look at an example. You guys can access this. There's an online debugger or online IDE called onlinegdb.com. Okay. And look for their C++ compiler. Here, they support step-by-step debugging. And this IDE is actually similar to our platform's code execution part. It's quite similar to this part. Okay. And now we want to debug, right? How can we debug? Move the integer I back inside the for loop, okay? And then we're going to save our code, okay? And then we're going to run our code. It's correct. Now, click on debug, okay, to debug our code. And wait, let me organize these tabs. And in order to debug step by step, add a breakpoint. What does a breakpoint do? So breakpoint means the program won't continue to execute. It will stop at this point and let you debug step by step. they let you analyze step by step what this program do. Okay. Okay, let's start again. Click on debug and click on start. So now it's telling that is at line 12, integer n equal 10. Okay, this is line 12. And the value of n actually is not defined yet because it's not initialized yet. Step, let's click on step over, next step. Next step, they are on for loop. On this line, n is already defined. N is 10, right? N is 10. And I actually is probably is not defined yet. It's just that we are just declaring I. And then click on step over again. You can clearly see that this for loop is not being executed. And why is that so? Because I is not greater than n. So this is not being executed. And thus, we are now at line 17. And the program ended. Okay. And okay, let's say we solved the issue already. Sometimes maybe we got another issue. So that we can look at how our for loop is being executed as well. We can analyze how it executed. So click on debug, click on start. So now our code is at line 14 because there is no breakpoint on the upper part. So it executes until the breakpoint, and here breakpoint like this, right? At line 14, right? And I is 0, n is 10, and I is lesser equal than 10, right? I is 0, n is 10, so I is lesser equal than 10. And thus, click on step over. Now, high will be printed out. Debug console. High will be printed out. Click on step over. See, high is printed out. Step over, that means we're going back to a loop again. Remember, this is the loop, right? So after line 15 is being executed, the code go back to line 14. And here in line 14, what is the value of I? I should be 1. So click on next. See, I is 1. And I is still smaller than 10. So I is still smaller than 10. And thus this will still be executed, step over. High will print out again and go back to line 14. So you can click many times to analyze what is happening. And right now, I is already X. Click on next. I is 9. Click on next. I is 10. So because 10 is smaller than 10, right? So it prints out high again. And then next time, X is actually 11. And it's not smaller than 10. So it will not be executed. It will be clearer if we make. It will be clearer if we define our I outside. Click on debug and then start and then step over. So I can click continue as well. Now I is X. Now I is 9. And then increment I by 1 again. I is 10. And then increment I by 1 again. See, I is 11 at the end. At line 17, I is 11. That's why this for loop is not being executed when I is 11. I is not smaller or equal to 10. Okay. So this debugging tools is very helpful. Sometimes your code is really very complex. You have no idea what's happening, and you can utilize this kind of debugger. So there are there are a few online free debugger. This is one of them. Also, there is another called I think called Rapper. The Rapper it's also one of the free online IDE with debugger. So you can try out as well. Other than that, yeah, I think that's all. These two platforms are quite good for debugging. And it's good that if you guys have knowledge of debugging through step-by-step debugging, it's really, really helpful. It's one of the most important skill uh in debugging. So this is OBUP switch, OBUP, and OBUP for loop. And just now I demonstrated about how to debug step by step as well. So next, we'll look into another kind of loop. This kind of loop is called while loop. Actually, it's very, very similar to for loop. It's just it's like if else is similar to switch case, right? So for loop is also similar to while loop. They looks a bit different. So sometimes while if you use while loop, it makes your code simpler compared to if you use for loop. So that's their difference. Other than that, the logic is pretty much the same. It's a for logic. Okay, so there's a recap here. So for switch case, if we switch like a character, we can match these cases, and there's a default case. So these are some of the recap. So for loop, there's an initialize stage, there's a the control stage, there's a increment or decrement stage. So and then there's the all your program statements are here. And then now we're going to talk about while loop. So let's look at a flow chart for while. So while loop is like in the while loop, at the entrance, at the entry point, immediately we check if something is true or false. If this is true, then we execute this while loop. Otherwise, if it is false, then we exit from the while loop. Also, if it is true, we execute our while loop, the statements, and then we go back to the while condition again. We check again the condition. And then if it is still true, then we execute again, and we keep executing it again and again. And if it is false, then it's terminated. Okay. This and while loop looks very simple actually compared to for loop. This is the while loop template. While and then your condition here, or your expression here, your condition here, and then your program, your statements here. So while is a very simple loop. As long as the condition is true, then it just keep looping. Let's look at an example. So we can define n equal to 0 outside of the while loop. And then in the while loop, in the condition checking here, we are telling that as long as n is lesser than 10, we are going to run this while loop. Okay. And inside this while loop, we are going to print out this string. And at the end of the while loop, we're going to increase n by 1. So, okay. And remember to wrap your statements, your loop statements with a curly braces. And at the end, increase your n by 1. So I think you can try to run it in the debugger as well. It's actually exactly the same logic as while loop. Okay. Start and then uh wait, start. N is 0. N is 0, and now we are at line 13. While n lesser than 10. Is n lesser than 10? N is 0, right? So n is lesser than 10. So this calculated into true. So if it is true, we are going to line 14, right? Yeah, we are going to line 14 because n is lesser than 10. N is 0, n is lesser than 10. So we print out 性相近，习相远. This. And then C++. Sorry, N++. Step over again. Now N is 1. Now N is 1. Okay. At line 14, now N is 1. And this will be printed out again. And N++ again. That means N will be 2. And if N will be 2, now N is 2, right? Is N lesser than 10? Yes, correct. N is still lesser than 10. So it will still be executed. So again and again, until N is 9. Until N is 9 right now. And N++. N++ will make N into 10. Now N is 10. Okay. Is N lesser than 10? No, because N is 10. It's not like it's equal to 10. It's not less than 10. So this while loop will be terminated. Will be ended. Yeah. Now we are at line 17. Step over. Yeah. So you can see it's very similar to for loop. So if we were to translate this into for loop, right? How can we write? So for integer n equals 0, and as long as n is less than 10, we are going to execute this loop. And every time in the loop, going to increase n by 1. So this for loop is equivalent to this while loop. It's exactly the same. Exactly the same thing. This for loop and this while loop is exactly the same thing. But in some conditions, in some kind of requirements, using while loop can make your code cleaner. But sometimes using for loop is better. So it depends on the scenarios on which one to use. And let's continue looking at the slides. So there's a requirement to print out while loop from 1 to 10. Probably we'll go through it later in the homework session. So observe the below list. Use a while loop to print out the complete list. So I probably will go through it as well later. Okay, and print out this list. Which is very similar to for loop. And then for loop, there's something we need to know. There's a keyword called break. What does break means? Break means to jump out of the closest level of for a while loop. For example, if we define a while loop here, right? And inside the while loop, if I equal to 7, we are going to break. What does break means? Break means jump out of the while loop. So jump out of the closest for loop or while loop. So the closest loop is while loop. So if I equal to 7, we'll jump out of this while loop. That means we will add the C out I next at the next line will be C out I. So in this example, if initially I equals 0, and then while I is less than 10, we're going to execute this loop, right? But then if I equal to 7, we are going to break out of this loop and continue to execute this. Let's analyze it step by step. Run, debug. And then we start. And then we are at while I is less than 10, I is 0, which is less than 10. Step over. Is I equal to 7? I is 0, so it's not equal to 7. So break is not being executed. So you're going to execute I plus plus. So I is 1 now. So we can execute until I equal to 7. Okay. 6. Now I 6 plus 1. Now I 7. Okay, I 7. If I equal to 7, break. Break means we are going to break out of this while loop and we'll be executing line 18 next. Yeah. So we break out of this while loop and we are going to execute this line 18, which prints out I. And this program is over. Yeah. So this is the concept of break. Break can break out of the while loop of for loop. So why would we have break keyword? What is that for? So break is giving us a much more control of our loop structure. So anytime if we want to break out of the loop, we can do so based on some condition. Yeah, for example, based on this condition, we can ask the program to break out of the loop. So it gives us more power to control our loop. And there's a question here. Will I plus plus still be executed if I equal to 7? So just now we demonstrated, right? No. If break is being executed, no. This I plus plus won't be continued, won't be executed. So the next line to be executed will be this. Okay. And there's a few samples for break usage. Probably we'll go through it in the homework session. Yeah. Next time, in next lecture, we'll talk about continue. Also, it's a keyword to be used in loop. We'll talk about continue, and then we'll talk about other than that. Or we'll talk about do while as well. So do while is a bit similar to while loop. But yeah, it's a bit similar to while loop. We'll talk about it next time. And there's some recap on the operation symbol. Yeah. So this week we already covered for loop and while loop. And next week we'll continue to talk about while loop and do while loop and the continue keyword. So stay tuned for next week. And let's take a break for 5 minutes. And then later at 10:06, we will go through some of the samples and homeworks in our platform. Hello guys, let's start going through some of the exercises together. I think we go through this already last week. What next exercise? Last week, I think we go through all the follow-up exercises already last week. So this is one of the questions in the slides, right? So you were given 5 grades and you need to calculate how many grades are fail, how many grades are pass. So you by using a for loop, every time inside this for loop, we read in a grade number, and then we determine if this grade number is greater than, like for example, a 59, then it's considered pass. So we increase our pass count by 1. Otherwise, we increase our fail count by 1. And then at the end of the program, print out the pass number and the failing number. Also, this is a fun question to do. Chapter 3. And then there's Maybe we go through this as well. About this. Okay. Based on the following for loop syntax, what should be the content corresponding to the numbers be? Drag the appropriate answer into the box. So the first one should be verbal initialization or assignment. The second part will be an expression that generates a Boolean value. So this Boolean value tells whether to continue execute the for loop. And then the third part is normally where the counter increment or decrement goes. The fourth part is the statements that should loop. And then there's another sample question. Please design a program that prints all even numbers between 1 and 100, with each number separated by a space. So how can we do so? To loop to print out all even numbers from 1 to 100. So we can have a loop like this. Loop initialize I as 1 until 100, and each time after a loop, I will be increased by 1. And to check whether the number is even, we can utilize this percentage symbol. That means the remainder after divided by 2. So if the remainder after divided by 2 is 0, that means I is multiply of 2. So, and then now we can print out I. Yeah. Also, we can optimize this as well. We can have integer I equal to 2, and then I lesser equal to 100, but every time I plus equal to, right? Because for each of these number, they are off by 2. And run this. Yeah. So they give the same result. Either you can write like this, which in this case, you're utilizing the remainder calculation. Or otherwise, a simpler one is to control a loop by adding 2 to I every time. Another sample here is, so we are required to print out 2x9276 until minus xtx. So what we can do is that we initialize our loop using 2x9, initialize it as 2x9. And we loop until it is still greater or equal to minus xtx. And then if we observe the pattern, right? So the pattern is that each of these are off by 13. So we just minus 13 in each of the loop. So now if you print this out, it will be 289 until minus xtx, and this is what they want. There's another question here. Cyclops wants to design a guessing game where a user first enters a password and answer, then has 10 opportunities to enter numbers. As soon as any of the entered numbers equal the password, display bingo, otherwise display you lose. So the user first enters a password and a password. The user first enters password, right? So we have to define an integer password and then input password so that we let the user to enter a password. After that, the user has 10 we have 10 opportunities to enter a number. How can I do so? 10 opportunities. So we can utilize for loop. For 1 until, this counting is from 1 until lesser equal to 10. And each time the counting variable increase by 1. And each time we are going to read a number from the user. So we're reading the guess. So if the guess is equal to the correct answer, is equal to a password, then it will print out bingo. And then we set guess correctly to true and we break. If we break out of this for loop, right? Then now we are going to execute this. If it is not guessed correctly, then we print out you lose. Why would we need guess correctly? So think about, what if the user use up all the 10 attempts? They use up all the 10 attempts, right? And then now we need to print out you lose, but we need to know whether previously the user we need to know whether the user guessed it correctly or not previously. If he didn't guess it correctly, now we have to print out you lose. So in order to know whether the user guessed it correctly, now we need a flag. It's a Boolean flag, which is initialized as false. So initially, guess correctly is false. So user haven't guessed it correctly yet. But as long as the user guessed it correctly, we make it true. And after everything is being executed, after for loop is done, now we are going to check if the user ever guessed it correctly. If the user guessed it correctly, then it prints out you lose. So why would we need a break? That is because the requirement here is as soon as any of as long as the user enter a correct number, we're going to end this loop. We're not going to ask the user to enter a number anymore, right? So we have to break out of this loop. How can we do so? So we can use this break keyword. This break keyword break us make the program break from the for loop. So the next line will be if. It will be line 23. Try to run this. So if I enter a number 24 and I will have to guess this 24. Let's say I guess 1. It's not correct. I guess 30 is not correct. I guess 24. Oh, it's correct. So bingo prints out. They print out bingo. What if I type 24 again? And then I guess for 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11. At the 11th time, it tells me that I lose. I think this is not quite correct. Like, right. Why I have 11? I can guess 11 times. This that has the user should only have 10 opportunities. 3, 4, 5, 6, 7, 8, 9, 10, 11. So he shouldn't be allowed. So maybe there's something wrong in this calculation. Yeah, but anyway, that's the concept, the idea for this exercise. Okay, next, let's get to the questions in chapter 4. Chapter 4, first question is, fill in the blank program and use a while loop to complete printing numbers from 1 to 10. So previously, we know how to print out 1 to 10 using for loop, right? But how can we do so using while loop? So for example, let's look back at the template for loop. Integer I equal 1, I smaller equal to 10, I plus plus, then it prints out I. So in order to change this into a while loop, we can move this integer I equal 1 outside. Okay, move this outside, and then move this as the condition for while loop. So you write while, and then the condition will be I lesser equal to 10. And then all of your statements here should be moved inside, also move inside this while loop. So our statements here is C out I. And then at the end of all your statements, now you can write this I plus plus. So now our while loop is exactly the same as this for loop. They're exactly the same thing. Just looks a bit different, but yeah, they are the same thing. And now we run it and it prints out 1 until 10. Okay, another question here. Display 197 until 2. And the pattern here is off by 13, right? Okay, so we can achieve this using for loop as well, but here they require us to achieve this using a while loop. So initialize your I as 197, and as long as I is greater than 1 or greater equal to 2, as long as I is greater equal to 2, then prints out I, and I equal I minus 13. It's quite straightforward, right? We go through this kind of samples many times already. So also if you want to make it I greater than 1, it's the same. Also it's fine, it's the same thing. So another similar question. So for this one, the pattern is off by 25. So every time initialize your variable as minus 77, and then loop until it's lesser equal to 273, and then print out I and increase your I. Yeah, it's quite straightforward as well. How about this question? Design a program where the user repeatedly inputs an integer and until the integer is a multiple of 7. Then display n is a multiple of 7 and the program ends. So this is where while is a good way to do it compared to a for. So we can hard code a true here. So the while will always be executed. Always be executed because this is always true, right? So always we read in, this is like an infinite loop, but not really because there's a break here. So this will be always be executed, and then we are going to read in the number. Okay. And then after reading the number, we are going to check if this number is a multiple of 7. If this number is a multiple of 7, we are going to print out n is a multiple of 7, and then we're going to exit from a loop. How can we do so? We introduce a new keyword, right? It's called break. So write break here, and it will break through from the while loop, and the next line to be executed will be line 18, right? So let's try this by ourselves. While for x 34. How about 14? 14 is a multiple of 7. 14 is a multiple of 7. Yeah. So and it breaks. So this is how it works. Also, now you might ask, can we achieve this using for loop? So we actually can do the same thing. For true. And then you copy everything here. So you can see that actually if the initialized part is empty, you don't have to write anything if you really have nothing to be initialized. And then for the third part, for the increment or decrement part, you actually don't have to write anything if if really you have nothing to write. But in this case, you can see that this code looks very ugly, right? So we should turn it into a while loop. It's more natural to do this in while loop. Just not that natural to do this in for loop because there is no initialize stage, there is no the increment or decrement stage. Okay, it's more intuitive or natural to do it in a while loop. This is when we should use while loop. But lot in terms of logic, they are completely the same. For 14, okay, 14 is a multiple of 7. So this for loop and this for while loop, in terms of logic, they are completely the same. But in this case, while loop is a better choice because it looks more natural. It looks better. This is a fill in the blank question. And so already some code is being written to calculate a random number. So after a random number is being generated, now we wanted adding the user can repeatedly inputs a variable n. If n is the same as a random number, then display bingo. And the program ends. It's similar to a previous question, right? So the random number is between 1 to 9. So we can guess between 1 to 9. And there's a while loop, while 1. What is 1? 1 means true because remember Boolean true converts to 1 and Boolean false converts to 0. So number 1 will be converted into Boolean true. So this is always true. This will always be run. And we let user to enter a number. If the number match the random number, X is a random number, a generated random number. So if the user gets it right, we're going to print out bingo and then end this loop. Otherwise, we ask you to try again. Let's try this. So enter. So the random number range is between 1 to 9. And let's say I guess 5. Try again. 1. Oh, I guess it right. What if I guess 6? Try again. 4, 3, 1, 5. Okay, now I guess it right. So it's quite a fun program. If you guys have access to this exercise, can try out yourself. And the next question is about continuing syntax. Please observe the following sequence and use a loop to display 1, 2, 4, 5, 7, 8, 11. Actually, this is a fun exercise. It's not easy to spot a pattern at the beginning. And the pattern is actually all the multiple of 3 are removed. This is the pattern. So we can look through 1 to 100, and if it is a multiple of 3, we just, if as long as it is not a multiple of 3, then we print out our I. But this loop is not quite correct. This is not quite correct. This is not the answer actually we want, not the intended answer, because we need to utilize while loop, right? So we can initialize integer I equal 1 while I lesser than 100 if I is not a multiplier of 3. It's not a multiple of 3. Print out I. And then I plus plus. Yeah. So we got the same answer as for loop. Okay, please create a program that calculates the sum of all numbers between 0 and 99, excluding multiples of 3. I think, okay, in this question have to use, it's better to utilize continue in this question. Actually, it's the same for the previous question. That means, because we don't want to print out, is it? Calculates the sum of all numbers between 0 and 99, excluding multiples of 3. So we can look from 0 to 99, but if the number is a multiple of 3, we're going to skip it. Okay, that's why we use a continue. We haven't touched on this continue yet in this class, but we'll talk about it next week. So yeah, stay tuned. But let's look back into a previous question. It is a basic continuous syntax question. That means if it is a multiple of 3, we are not going to print it out. So if it is a multiple of 3, we're going to continue. We're not going to print it out. Otherwise, I plus plus. But still, remember to I plus plus. If it is a multiple of 3, I plus plus and continue. Is this correct? This is correct, but 3 doesn't. This is one of the sample usage of continue. So continue means we skip the code below, and we execute at the top of the while loop. We go back to the top of the while loop again. This is the usage of continue. So how about break? Remember, break means if you have a break here, break means we're breaking out of the whole while loop. So the next line to be executed will be line 26. But for while loop, but for continue means we're going back to the first line of while loop, and the rest won't be executed. We're going back to the first line and starting it, and start this while loop again. And we'll talk about it more in details in next week. So see you guys next week. Thank you for listening. Bye bye.